Hey, good evening, everybody. Welcome to the April the 6th version of the virtual night sky. Welcome to April. Summer is coming. I think you've all noticed it's a little bit warmer. I hope you've also noticed that the sun's staying up just a little bit later every single night. And so we have more evening time before the sun sets. And the other end is also true, right? The sun is coming up a little bit earlier. So morning seems to be hitting us quicker than it used to. I think this is a great time of year. I love the springtime. I love all the activity that goes on this time of year. And so this has been great. If you are visiting us for the first time, I absolutely want to welcome you to the program. We've been doing this now for, it will be 2 years next month. We started this program every other Wednesday as our response to COVID when we had to close our activities on campus. And we've decided to keep going, and we'll do this just as long as we feel like it. So we're very excited about the program tonight. We're actually going to talk about scientists and citizen science and what makes a scientist and those kinds of things. We'll also have a little segment where we're going to visit the night sky. I better give you a little update on the planets because there's some really amazing things going on in the morning and some things to watch for over the course of April if you like to get up before dawn, which I do sometimes. And we're also going to have just some updates on some amazing things that are going on and some resources. So welcome. We do the webinar format here, so we don't use chat. So if you really feel like communicating with us, and we want you to feel like communicating with us, we actually have a way to do this through the question and answer button on your screen. And that question and answer button could also be a comment or a thought or anything you want. But if you just get an idea you want to ask about during the program, we have a couple of really amazing guests tonight that should spur some questions. Please just go ahead and put them in there. And there's a team of people in the background that will help answer those. We also have closed captioning. We do that. You're kind of in charge of how that looks on your screen. If you want to use it, you can. If you don't want, you can just actually X out of the closed captioning as well. So it doesn't have to be there for you. We use it to repost these programs. It makes it easier for us. The other thing is we always want to welcome school-age kids. So we send notices out to teachers across the valley. And we encourage you to encourage your children and to just kind of keep track of this and watch every other Wednesday night. There's always something to do. We always have something to look at in the night sky. And we really have a special thing for our audience tonight. We're going to turn you into citizen scientists. And so you'll hear about that kind of towards the end of the program. Welcoming the people that help run this thing, Kim Baptista, as always, puts these webinars together. She does an absolutely amazing job. She's the one that communicates with you. And she'll send something out at the end, after the program. And that's also an opportunity to say how you liked it, and if you'd like to see something, or the parts of the program that you really like, and those are the kind of comments we're looking for. Meg Hufford, my colleague, is here. Things have been getting really active at our building this month. It's sort of natural in the spring, but this is sort of coming back after COVID. Things seem to be a little bit wild. So Meg and I are kind of like running like crazy, but we're here to spend an evening with you too. And Alicia Hyatt is with us. She's a former student and now an employee. She's an education specialist for us. And Armand Dalla and Alex Blanche are also students working in the background. And you'll hear from all of them at some point during the night. So I think that's kind of a feature that we've been doing. Before we go too much further with the introductions, I mean, the beginning of the show, I really want to say I've got two really fun and amazing guests tonight. They are both teachers, instructors. They're both doctors in our program. Professor Garnero, I'm introduced first, and Dr. Nearman will be with us towards the end of the program to help with citizen science. But I just love the fact that we have access to a huge range of faculty, a huge range of research interest, and something struck us as we're putting it in our program, a very special project that Dr. Garnero is working on. So without any further ado, let me invite Ed Garnero to the screen, and we just talk a little bit about him and his research and a special project he's working on to share with you. Ed, are you there? There he is.
I'm here.
How you doing?
Good. Thanks for having me. This is
you
fun.
And your little sort of your Earth models back there. So I'm going to say this sort of, you'll have to go into a little bit more detail than I will, but Ed, you study the inside of the Earth, right? I mean, is this your thing? And we can see that in the background, is it?
Yeah, I'm a Earth and planetary interiors researcher. We want to know how planets, what's going on the inside, because the inside relates really directly to what's at the surface and vice versa. So, and my breed of science is a seismologist. So wherever there are quakes and sensors to measure that, we do our work. So that's the moon, that's the Mars, and especially Earth.
So it's just another one of those places where what we learn about the Earth can be sort of studied on other planets and used to sort of further our knowledge of what's going on, and vice versa, right? So we can learn things from planets and it applies to Earth. So
Yeah.
I think that's awesome. And it also happens to be teaching a class in the Marston Theater. We're sort of kind of near and dear to me. So we see each other about once every other day. But the reason you're on the program tonight is you started this really amazing project where you're recording people and interviewing them about sort of being scientists. And so tell us about the project and what's going on. And I think we'll get into some of your videos here in a minute.
Yeah, it started because I teach this 200 student Geology 101 class in 2 sections of it this semester, so 400 students. And I've been more and more disillusioned with, like, well, maybe that's not the right word, but how do we teach information? How do we convey information when we all have the information on our smart devices, right? So I started thinking that, well, maybe I'll just kind of do an inquiry about what is science? What is scientist? What is scientific? And I'll do it through interviewing people. So I started just on my iPhone recording people in these impromptu interviews, the 10 to 20 minutes of interview. And I produce it down to a 2-minute portrait style video talking about science. What is science? What do you do? To try to humanize science. I felt that would be more interesting for the students than all of the details, which they just have access to by asking Siri or Alexa.
Yeah, I agree. I mean, you could just look up anything. I think just before the show, I was looking up the distance to a little cluster we're going to be talking about tonight. So
Exactly.
we don't have to know anything anymore. We just look it up. Actually, I think let's get into this and do the first one. So Kim, I think you're going to launch you'll show us the PowerPoint, and we'll sort of launch some videos, and you can kind of talk through what we're seeing here. Thank you, Kim.
Yeah, and so I show like 2 of these per lecture. That was my approach in my Geology 101 class. And we're going to start off with Eleanor Sauer, who was an undergrad at ASU and now works in one of the School of Earth and Space Exploration's laboratory. And I chose her, she's just a ball of enthusiasm, super inspiring. So let's go ahead and listen to Eleanor.
I am a scientist. Hi, my name is Eleanor Sauer. I am a research technician within Dr. Hilary Hartnett's Candy Lab, which stands for Carbon and Nitrogen Dynamics. I have degrees in biology and environmental chemistry, and then minors in philosophy and sustainability.
Wow, that's a full plate.
I really want to run the gauntlet of ASU and get a little bit of everything if I could, get my money's worth.
As a younger person, were you always drawn to the environment or Earth?
Yes, for a long time I was like, I'm going to be a lawyer when I grow up, go to Stanford, and I realized that is not what I'm interested in at all. And instead I think back to being a kid in my backyard playing with little roly-polies, finding critters in the yard. Animals specifically is what I was really drawn to, and then by extension, if you love animals, you love nature and the environment.
When you were super young, did you know that there are careers in science?
I feel like I knew like the big money-making careers, like the lawyers, the doctors, the super spelled out degree paths that you could take. But even now, the idea of being a scientist is kind of ephemeral to me. It's like a constantly changing, developing idea, and I think there's a lot of different paths. Science is just so cool because it's so broad and there's so many places you can take it, and so many people find their niches in different things, as opposed to being something like a doctor or a lawyer where it's just like a straight shot path and you know what you're going to end up as.
You have enthusiasm about science.
Thank you. Man, you can get into the nitty-gritty science classes and sometimes you're kicking yourself and you're like, why am I even doing this? It's just so great to take a step back, remember why you loved it. I don't even know if I'm going to be a hard scientist in my future, but I know I will never lose the love and the appreciation and explaining to someone, why do we see color the way we do? It's like once you know that knowledge, you're like, dang, that is so cool. cool.
Favorite food?
Ramen.
Favorite book these days?
There's a book called Circe, which is an adaptation of ancient mythology, which is really great.
Song you would recommend for me?
I love Lizzo, so Lizzo's Rumors.
What is a scientist?
Anything you want it to be. I am a scientist.
And that's excellent. And I love the little flash sort of little design things that you do. It's excellent. And Eleanor, she can't be beat. She's just like so enthusiastic about what she's doing. So,
I almost get teary-eyed. She just said so much.
oh, I am. I know. Yeah, absolutely.
Yeah.
It's so fun. So
And
okay.
yeah, it's so cool. And I did it in portrait mode, made it fast paced because I was like, these kids are on TikTok and social media where it's constant rapid fire of information. So I'm not really competing with those things, but I just thought this is something the younger generation is more familiar with. So
Good. And you play these for the students in your classes, right? And they must respond well to this. I'm sure they're just like
they do. The first time I played the first video, a bunch of students came up after class and just said, wow, that's amazing. How do I change my major?
Good. Hey, let's move to another one. So I think we've got another one here.
Yeah. And so this is a graduate student, Adiolo Adiroju, and another remarkable human being. So let's go ahead and press play.
I am a scientist. Orúkọ mi ni Adeolu Adiroju. Mo wá láti orílẹ̀-èdè Nigeria. Mo dẹ̀ jẹ́ ọmọ Yorùbá. My name is Adeolu Adiroju. I'm from Nigeria. I'm from the Yoruba tribe. I'm a PhD student at ASU.
What do you do for your research?
I search the inner part of the heart using seismic waves. Seismic waves are waves that come from earthquakes. So I use earthquakes to see deep within the earth.
Were you always interested in science?
I think I've always been interested in science. When I was in high school, my geography teacher was trying to explain the concept of plate tectonics, and he tells me about the heart moving. And for like a whole semester, I tried to go check those rocks to see if they were moving. I literally did not see any movement, so I was disappointed. But I feel like those were some of the small things that drove me to being a scientist and doing what I'm doing right now.
What do you love about your job?
My job is actually very fantastic. I consider myself as one of the few lucky people on Earth because I can look into the Earth, I can tell you things about the Earth without actually getting there.
You're doing a PhD where you study the inside of the Earth using waves, but I'm also aware of a project you're working on regarding geoscience education back in Nigeria.
This is a project where I'm trying to engage with students to know about the quality of the geoscience program and also to make inquiry about how aware are they about employability skills. It's going to help students measure themselves in terms of where they are and where they should be to be able to get them employed after their program.
What's your favorite planet?
I think my favorite planet is still be the Earth.
Did you collect rocks when you were a kid?
Yes, lots of them.
What do you hope to do when you finish graduate school?
One part of me love research and one part of me love being an entrepreneur. I don't have a decision yet. I'm a scientist.
Super cool. So we have Ed and I kind of run into students all the time that do their undergraduate work in a foreign country and then choose to come to the States and come to our school for graduate work. This young man did that, right? Did he do his undergraduate in Nigeria?
Yep, and he got a master's in Nigeria. And
okay.
Yeah, and he's part of this effort of mine to really to show that the scientific community is so diverse. We're not all older white men. You know, there's a diversity of age, gender, discipline of study, country of origin, color. And that's why I have people from other countries introduce themselves in their mother tongue. And it's really like we are all scientists is kind of one of the points I'm making. We're all curious.
And at least the first two are really happy people. I also love the fact that he goes back to Nigeria and he's working, so he's like seriously working with students and mentoring back there, right? So I think that's incredible. So,
well, one of the things I think is that we're all curious, and this little movie making stuff, like I said, I record 15, 20 minutes of people. I can cherry pick those gems that where people are in their own skin, kind of resonating with their inner curiosity, because that's what we're having dialogue about. So it's really fun to see people kind of articulate the flavors of what is science and what is curiosity. So they're all happy.
Super cool. Hey, let's move on to the third one. So this, we've seen an undergrad student. I think we've seen a graduate student, and introduce this amazing lady.
Yeah, so Katie Coleman is an ASU professor in practice associated with the School of Earth and Space Exploration, and just a remarkable human being, and has such a unique perspective on science and doing science and curiosity, having orbited Earth for such a long time. But I don't want to give anything away. Let's watch her video.
Okay.
I am a scientist. My name is Katie Coleman. I am a former NASA astronaut, although I think like once you're an astronaut, you're like always an astronaut. But I started off as a chemist.
You have a rich history. You were in the Air Force. You have a degree in chemistry, PhD. When did it occur to you that you might be an astronaut?
Not until I was in college, and Sally Ride, who's the first American woman astronaut, came and talked in an auditorium at our school. And I just thought, wow, maybe I could try to do that.
You floated in space, looking at this beautiful blue bulb for nearly 6 months.
Looking back at the Earth, there's two things. One of them is this huge thing that never leaves you, which is you look back, you realize everybody's there but you and the people on your spaceship. And so you realize that where you come from exactly on that place that is home for all of us just seemed so unimportant, really, because it was clear that if we could only all find each other and be connected, we could solve some of these really big problems. But that's the other thing. From that vantage point, you just see that there's all these places to be collecting data. The data is everywhere, like the Earth is speaking, and are we listening? And being up on a space station is like being up on a listening post. I'm wearing my jacket, and I don't actually wear it around my house like all the time, but I do wear it for things like this because I think that just the way we all grow up, it seems like the people that get to do things like this are people that always knew like which way to turn, what to major in, what school to go in. And certainly that's not my experience. You know, I wanted to wear this so you realize that like when I take this off, I'm a regular person. And you wouldn't just go, she's an astronaut. And that means that you have to look at all the other people around you, especially at a place like ASU, and think, what jacket aren't they wearing? Because you don't know who they are until you ask them.
Give me a book that you would recommend.
Ooh, this is called Saving Us, A Climate Scientist's Case for Hope and Healing in a Divided World. Katherine Hayhoe, she acknowledges that things that are hard to talk about between people, no matter what it is, there's some ways to find a path where you actually share what you have in common, and you find ways to talk about these things. And it gave me great hope to read this book. I like science fiction. One of the series that I really like is by Mary Robinette Kowal. What happens if back in 1950, we realized that in no uncertain terms, we needed to leave the planet? How would we get to the moon and Mars? And the only people that were in a position to figure that out was a mixture of women and men and people of color, people with different religions and different countries. I liked seeing how that could all work. And it also validated a little bit of my experience, you know, being a person that doesn't look like every other astronaut or feel like every other astronaut, kind of helped me come to terms with some of those places where I didn't feel like I fit. I am a scientist.
And we've known Katie now. She's been a professor of practice with us for about 2 or 3 years, actually, for a little while. And she does make it a point to come interact with our students quite a little bit. So how lucky are they to actually have a real astronaut? But in this video, the one that stood out for me is like, what jacket aren't you wearing, right?
Exactly.
When you're walking down the street, you know, what are you that you're not showing me right now today? And that was really pretty. That's pretty awesome.
Yeah, when I played that for my students and that quote, we talked about it afterwards, they were all just kind of like, wow. And, you know, just to acknowledge that every one of us is special and unique and has some jacket we may not be wearing. It's so cool. I mean, I interviewed all levels, from undergrad students who have no idea what they're going to be doing in their life, up to our president, Michael Crow, the former CC faculty who is the next director of the Jet Propulsion Laboratory, JPL, and vice president of Caltech.
Right.
science writers and just different flavors of this thing we call science. And it's been so fun. I've recorded a ton of them.
I know. And so, just what inspired you to start, and where does this thing take us? I mean, are you just going to keep recording? And actually, if you're recording and sharing new ideas and new people all the time, it doesn't have to stop ever. It really doesn't finish, does it?
I know it's a bit addictive. I spent the whole winter break recording these and producing them, and I got super behind in like research and mentoring and other things. And so I've recorded 50 so far. I've produced half of them, and I'm producing as I go. And there's a ton of people I'd like to go. I would love to just keep doing it. And then eventually these go in social media and on the online. So my hope is the fall semester, we kind of put them out there to the public. So, because it's fun, it's inspiring. And the students, they were like, oh, I'm a business major. The business school should be doing this. I'm a business person or whatever, right? Like it sort of paves the way for inquiry, because it's about what makes us curious and to follow that, you know?
So curiosity comes up, right? So that's
absolutely.
It. So what does it take to be a citizen science? I mean, what about we're not going to school, we're not astronauts. Am I a scientist?
Well, yeah. So here's the thing, my take on it, and if I ask all the people I interview, they may have different views of this same thing. Is, for me, curiosity is science, being curious. Those of us who get paid for it, we have some organizational skills as well, you know, to put our observations from curiosity into some kind of structure. And there's so many flavors of what we might call science, but we're all innately curious. Therefore, we're all scientists, whether we are putting it into our brains that way. Like, I'm a scientist. So many people are like, I'm bad at playing an instrument, or I'm bad at computers, or I'm bad at science and math. But no, we're all curious. So every viewer right now, Rick, you, me, you know, like, even for me, it's weird to say I'm a scientist, even though I am, but we're all curious. So we are all scientists. Therefore, we're all citizens. So A equals B and B equals C. We're all citizen scientists.
And where does it lead us? I think that's great. I mean, take your curiosity where it just, I think it's the notion of exploration, right? You want to find out the things you don't know, or you want to just reinforce what you do know. And so, yeah, all of those things in there.
Yeah.
It's a great project, and ASU is lucky to have an amazing professor like you, a geophysicist, right? And somebody that just, you know, wants to work their winter break putting together these incredible videos. And so I think it's super cool.
Thank you, Rick. In summer, here I come, make more.
Okay, we're going to take a bit of a break, but this is a lead up also. So I'm going to remind the audience, and sort of towards the end of this program, we'll have another guest, and we're going to actually take you into a citizen science project. We're going to actually have you like go out and do something in the next several days and report back to us. So you'll learn about that in a little bit. I'm going to take a little bit of a break. I'll be back and kind of show you some night sky things and some stuff, and then we'll introduce you to your project. So, Ed, thank you so much for being on board. I think it's amazing.
Thanks, Rick. Thanks for having me
to the show. All right. I'm going to welcome Alicia, I think, to the show, and maybe Alex. And so, do we have any? I forgot to remind people to keep asking questions. I know we sort of forget that, but put questions in the question box. And Alicia, I think, has a couple polls for us. And you look very Aurora tonight, Alicia.
Thank you. I thought I'd change it up a bit. I still have my Psyche asteroid lanyard, or my Psyche mission lanyard, so I'm all space for you. But with that being said, I will launch a poll, and one of these questions will make sense after our next presenter comes up. But thank you so much, Dr. Granero. So how many virtual night sky presentations have you viewed? And then our second question is, have you ever participated in a citizen science project? So that's a very important question, and you'll understand why in a minute. So But with that being said, Rick also mentioned that we have our Q&A available. So please ask any questions that you may have, and we'll try and take them as they come. But with that being said, I'll end our polls. And our first one, it seems like most of us, 61% of us, have seen at least a few, right? That's awesome. And 12%, this is their first one. So welcome welcome back or welcome first timers, and then welcome back those who have seen us before. And then for those who have or haven't participated in a citizen science project, it looks like 83% of us haven't. And so we have a really exciting opportunity and a really exciting guest for you to help explain what the citizen science project is.
That sounds great. Well, thank you. Thank you. Yeah, and so for those of us who trying to just keep following, thank you very much. We try to do something a little bit different every week, every other week. I guess we are actually on a 2-week schedule. And we also try to give you something to look for in the night sky. And so I've got just that. So we spent the first whole part of the year just kind of inviting people to sort of understand how the sky works, got some fundamentals done. Today, I wanted to share just a real quick planet watch with you, just so you can sort of see what's going on here. The important thing here is that the planets are always changing. This is sort of where all of the planets are right now. And you see in this particular scene, you've got the orbit of the inner planets. The sun is like that little thing in the middle. I've diminished its light because it just sort of like gets in the way there a little bit. But you see the blue orbit is the Earth. You can see, I think I can actually sort of show you this on the screen. I can. So let's see. Get down to that view. There it is. So here is the Earth right here. Venus is over here. Mercury is just kind of behind the sun over this way. Jupiter and Mars in the background here. And you'll see some more in a minute. And I think I've showed you this before. If you just sort of draw an imaginary line right through the Earth, right through the sun, right through this whole part of the sky right here, just kind of that way. Everything on this side of the line, everything to the right of the line are objects that's viewable in the morning. And that's before sunrise, right? So that's the morning. So if you want to see these, and I'm going to show you something that I think you're going to want to watch for. That's why I introduced you to this, is if you want to kind of get used to this idea that maybe a couple of days in the next month, you're going to want to get up before sunrise, get out and look into the eastern part of the sky and see some planet stuff going on. Just the opposite happens over this way. So everything on this side of the screen, to the left of that Earth-Sun line, are things that you can start to see in the evening. And so if you look here very closely, you see Mercury is moving in this direction. So, I'm going to give it about 4 days. I'm going to say 4 or 5 days, and then start looking for it in the evening sky. If you kind of keep track of where the stars are that mark the evenings this time of year, then you'll see Mercury will sort of appear as a star out of place. It'll just sort of be there for a little while. You'll see it for several days, and it'll move around just a little bit, and then it'll dive back into the light of the sun, and we'll lose it again. So unfortunately for us, or fortunately, depending on kind of how you look at how you sort your time out, right now is not the best sort of, it's morning viewing, not evening viewing. But everything changes. And at the end of the year, we'll begin having a different conversation. We're going to be talking about evening planet viewing and not the other. Check this out. I've moved to a position where you can see the Earth again, but look at Mars and Saturn in the background, right? What's going on here, and you can check this out. We go out in the morning sky. I think you'll be able to see these two objects. Let me zoom in just a little bit, but you'll see Mars and Saturn are just passing each other. They're just kind of right in the same part of the sky, and so we call that a conjunction in astronomy. It doesn't mean anything more than those two objects are near the same ecliptic longitude, and that means they're going to be right next to each other. They don't exactly sort of like run into each other. Mars's orbit, I think I can show you here in a little bit, is just a little bit lower than Saturn's orbit. So it's not like they sort of like bump into each other, but you'll see that movement. Now, I'm going to predict something for a little while. Actually, let me just kind of move ahead in time. Sort of, we can do this because we can. I'm just going to kind of move forward. little bit, you'll see everything kind of starting to move. I'll try to keep the Earth caught up with the scene here. But watch Venus and watch Jupiter. See what's going on? The Earth is moving. We're changing our view. I'll stop that right there if I can get my hands on the switch really quick. And so what we just saw, what I just kind of showed you on the screen there, is because the Earth is moving to the right, because Venus is moving to their left, and because Jupiter is kind of staying in the same place, we have this will be a really bright and wonderful conjunction, and it will come up at the end of April. So we'll have another show between now and then. I'll tell you about this again, so you have time to watch for it. But here's my recommendation is if you feel like this, if you want to get up before dawn, get out and kind of take a look at the morning sky in the east, you'll see these planets. You'll see all four of these, Mars, Saturn, Venus, and Jupiter. But if you watch over the course of August, or April, I'm sorry, just keep checking about every 3 or 4 days, you'll see Venus and Jupiter get closer and closer and closer and closer. And then they'll have this really remarkable little conjunction later in the year. So that'll be kind of fun. I'm going to kind of change views here now, and we're going to introduce you to some stuff that's going on in the night sky, stuff you can sort of look at. And this time it'll be in the west, and this time it'll be sort of something that's a little bit easier to watch because you can see it in the evening. So remember what's going on, right? The sun is setting a little bit later. And the stars that you can see on the screen here are sort of just sinking into the western horizon. Every single day, incrementally, they're just moving a little bit more towards the horizon, and that gives them it means that they're getting closer and closer and closer to the sun's glare. Both things are happening. They're moving down, but also the sun is also changing position, so it's kind of up in our sky longer. And we've been talking quite a little bit about this part of the sky. Let me get my little pen out so I can draw some stuff for you. We've been talking a lot about the sky in this area, and let me just sort of reminder that this is Orion over here. Kind of looks like a bit like an hourglass. You see the belt stars of Orion right here. The star up in the upper corner, that's Betelgeuse. This one down here is Rigel. We've been starting there a lot, and we've been looking at stars kind of in this direction and the relationship. But now I want to focus the other way. There are also other stars associated with the constellation that will be very, very difficult to see in the sky, but there's this whole big club thing going up this way. Orion's head is going to sort of be up here in the top of this thing. And then he's got another arm kind of coming out this way, and he's holding what almost like looks like a bow, or like a bow and arrow kind of thing. Most star charts and things like that actually show this as like a lion pelt. It's just sort of like he killed a lion, he cut the pelt off, and then that becomes part of his personality. It's sort of like the idea that the great hunter can derive the power from the hunted. And what's more powerful than a lion, and then therefore sort of, what's going on there. And so this is sort of just another look at Orion. We've been looking at Orion in color. We've been looking at Orion for a nebula. We've been looking at Orion for brightness, all of this kind of stuff. But let's not forget that there's really some really rich and wonderful mythology that goes on in the background. But I also sort of want to show you how that interacts with another constellation. Just right next to Orion is Taurus the Bowl. And I'm just going to kind of make a little V shape here, and you're going to hear about this V shape more and more and more. This becomes the head of the bull, right? I'll give him some ears out here, and he's got his horns. The points of his horns kind of end up here, kind of over by the moon tonight. I think this is tonight, isn't it? Yeah, April 6th. It's about 8:15. Right after the show, you should be able to go out and sort of just see this particular relationship. There is also in mythology a bull body that sort of like goes back this way, and there's sort of that whole thing happens. But the main thing that you're going to look for, the main thing that you can see, is this little V shape right here. And that is also an astronomically significant thing. We call it the Hyades. And so I'll show you that a little bit in another simulation here in a minute, but it's an open cluster called the Hyades. The other thing going on in this part of the sky which we cannot forget, is just over here. It doesn't really figure as part of the sort of like the main body parts of the bowl, but it is an object within Taurus. And I think people know this as the Pleiades. You know that this is the Seven Sisters. It is also an open cluster. It's a little tiny little grouping of stars that kind of has a distinctive shape. It sort of looks to me like a little baby dipper, you know, like a little mini dipper. It's not, but it has also had sort of some rich historical lore associated with it. And so what we're going to do is I'm going to kind of leave this. I'm going to set up another view in another program and kind of change that. But as I'm doing that, I wanted to introduce you to our next guest. You have met her before. This is Dr. Karen Nearman. Karen is also really involved in public outreach. She's a really good friend of all of us in our department. She is a teacher in her own right, and she runs the labs for the school this year. And but she also kind of has this really great affinity for culture and lore and how ancient people have seen the stars. So I'm going to introduce Karen Nearman, Dr. Nearman, to come to the screen and just kind of tell us a little bit about the Pleiades and what our subject is here. And while she's talking, I'll get another little scene set up here so you can see what we have going on. Welcome, Karen. How are you?
I'm doing great. Thank you, Rick. Yeah, so one of my favorite things, right, is that when everyone in the world has access to the night sky, we all had more access to the night sky before light pollution was occurring. But that means that many of the stories that we can tell about what we see in the sky are different depending on the cultural background, depending on what's important to those people, what's in their area, what their families are like, what their friends are like, what animals they have, what the weather is like. And so we can look at and learn about the different cultures as we look up at the sky. And so one of my favorite stories, one story that I learned actually many years ago, about the Pleiades is that it's a story of dancing children. And this comes from the Onondaga people, which are from Western New York area. And the part of the story says that the children were out dancing and they danced for so long and they were away from their family that they began to get hungry. And the children felt very lightheaded. And even though they'd been warned against this behavior, they kept going out and doing it again and again. And one night they began to float upwards into the sky. And we can still see them today dancing together as a circle of children, as the Pleiades. Another culture in a different part of the world. So you may have heard of Subaru cars. So the Subaru logo on a Subaru car is 6 stars. In Japanese, that group, the Pleiades, is known as Subaru. And one thing I recently learned about that is that the name Subaru is a little bit hard to translate exactly, but it means something like gathered or grouping or united, referring to that group of the little stars. And it's actually significant in many of the different groups among the islands of Japan as a marker for calendar or agriculture or fishing. So that's one of the important things. So that's something to look for when you're out and about, is next time you see a Subaru logo, you can see what it looks like.
I think you can see the little Subaru on the screen there for those of you that have Subaru. So something I learned was interesting. I read an article about this, is they call it the Seven Sisters, right? And there's actually 9 stars that are named and important in here. So there's Atlas and Pleione, and those are the ones that are just sort of just up and to the left a little bit, just that little tiny thing. And the rest of them, the big bright ones in that grouping, are indeed the Seven Sisters, and they all have a name, and I can't remember all of them right off the bat, but there's sort of like the 9 main stars that are named. And then if you look at it just from city lights and just sort of casually look in our eyesight, you really kind of only see 6. And some people have enough eyesight. I think, Karen, you were talking about your husband, Patrick, that has a better acuity for looking at it. He probably can see 8, but hardly anybody will tell you when they look at it, they see 7 stars. And so it's kind of and there's a story behind that too, that one of the sisters actually married a mortal and her brightness diminished as a result of that. So I guess there's another explanation for that. But hey, let's talk just a little bit. So I'm gonna really want people to kind of seriously, we'll go over and over again, kind of how to find these things in the sky and what to look for. But I wanted to talk a little bit about the science here. So these are actually open clusters, right? Is that what this is going on here? And
That's right. So when we call them 7 sisters, they actually kind of are sisters. They are siblings. They were all born together out of the same cloud of gas and dust. And so then over time, an open cluster just means that the stars are not gravitationally bound together forever. So over 1 billion years or so, they'll start to drift apart from each other. What that means is that maybe our sun once was in one of these open clusters, and maybe the stars, some of the stars that we see, maybe those were our siblings.
It could have been, right? And just over time drifted away. Are
Just
they
drifted apart.
do stars, does that just normally happen? Could we just say things tend to drift apart, or do both things happen?
Both things. I mean, both things happen. You because there's such a large spacing between most of the stars, and you really have to have a whole lot of mass in a small area to be able to be gravitationally bound. So stars are mostly formed in groups, but they don't always hold on to each other.
I get it.
Hold on to their neighbors.
Pleiades open cluster, and now I've opened up the screen a little bit, and can you see my V there? Does everybody see? So to remember, I was kind of walking through the head of the bowl and this little V shape that I have centered there. It's also an open cluster, right? So these are just 2, they just happen to be kind of in the same part of the sky. But if I remember right, they're at very different distances. So the one on the left is called the Hyades. The one everybody knows, the famous one, that little sort of like little dipper thing, is called the Pleiades. But the Hyades are also an open cluster. And so the face of the bowl, right, is actually also related, I'm guessing.
That's right. Yeah, they're at different distances and they're at different ages. So that can tell us something about how stars are born and evolve and move through their lives. So
Karen pointed this out to me before the show tonight, is that you can actually take the belt stars of Orion and sort of just kind of trace across, and my line is a little bit crooked, but there, and this is how you're going to find this. And so it's the Hyades, it's the V, it's that little shape in the sky that we're going to sort of introduce to you as a citizen science project that we have come up just for our audience. And so this is sort of, get used to this, figure out how to do this, take notes if you have to, but we're going to ask you to find that V in the sky, and we're going to tell you when to kind of look for it. Before we get there though, I just wanted to show you something. The other system here I had up has a really good way of sort of, I'm going to just, this kind of looks a little bit by a jumble, but you'll see Taurus and Gemini are constellations of the zodiac. So Taurus is the bowl, and the V shape, oops, let me use the right pointer so you guys can see what I'm doing here. The V shape of that, of the bowl's head is what we're looking at here. The horns go up and sort of like relate to this other constellation up here called Orion. I can actually, I'm going to turn off the art and turn on sticks here for a little bit, just so you can sort of, it might make it a little bit easier to see. So you see Orija is up there, and the horn, the star at the very end of the right horn in this particular case is called Elnath, and it's actually a star that it shares with the constellation of Orion. I'm going to turn these off here for a second, just all constellations off. Give me a moment so I can kind of just get them out. And then I'm going to show you something really kind of cool. What I did is I sort of set up a little simulation. Didn't mean to do that. Those guys gone. Those guys gone. What we can do is we can actually fly out to the cluster. So I'm going to center the sort of the V-shaped cluster on the screen. And so remember, you're looking at a V, and the bright orange star that you can find by following the belt is called Aldebaran. And it is actually, you're going to find out here in just a second, that it's actually way closer to us. Oops, hang on a second. I did something wrong. I have to recenter. Got it. Is okay. Going to happen. And now I can fly out. So I'm going to sort of do this. Watch what happens. Aldebaran is going to go past us really quickly. So we've just left the Earth and we're flying into space. And the really, really bright red star, you can see it's just kind of like running by us. And then look in the background there. I'll move back a little bit, kind of recreate the V. There it is. There's the head of the bowl. And then I'm going to kind of just move out. As we get a little closer, you see it's not just a couple stars, but it's a whole bunch of them. And you can sort of see we can actually fly around them a little bit. Isn't that amazing? So when you're out there looking, right? So we're going to send you out to look at this particular V, the Hyades, the head of the bowl. But we're also going to kind of assign you to like do a little observation and send us a note. But while you're doing it, just kind of think of that as a big cluster in the sky. It's about 150, 152 light years from us. I mean, there's a range in this cluster, so they're probably 3 or 4 light years across. And so approximately 150 light years from us, and absolutely really beautiful. You can also see in this simulation there's some redder stars, some golder or yellow. It doesn't look like there's any blue stars for us here. So anyway, okay, that's that.
Yeah.
Yep.
That's right. So and the Hyades here is actually, they're an older cluster of stars. So if all the stars were born at the same time, some of the more massive stars that would be that bright blue have already died and gone supernova. So leaving behind those yellower and those red ones that are still living their lives out. They're much longer lived. So,
okay, I'm going to go back to the other screen just so we see here. And here's what we're going to do. So we actually kind of conceived of a little project that you guys can do with us. And so what we're going to ask you to do is go out, and we've given you 3 nights to do that. If you want to go out tonight and look, you'll probably find these in the night sky, but not tonight. So on Thursday, Friday, or Saturday, or all 3 if you'd like, we want you to go out and look towards the western part of the sky at between 7:45 and 8 o'clock at night. So you got about 15 minutes. That's a good little window there. By that time, the sun will be down for a while. It'll be darker and darker and darker a little bit, and it's below these stars, before these stars go below the horizon. So we're gonna, and you know how to find it now. Orion is really easy to find. Follow the belt, move yourself over to the V. Look for that very, very bright orange star called Aldebaran. And what we're going to ask you to do is count the number of stars that you can see within this little V, right? So it's a small object. It's not very big. You can hold your fingers out as a guide to sort of see this. And sort of, we're going to ask you to count the numbers in the V. Karen, what else do they have to do?
And then once you count that, take a note of the sky conditions. Is it, are there a few clouds? Is it perfectly clear? And then also your surroundings. So what the purpose of this project is actually to think about light pollution in your area. What that means is different artificial lighting, right? The street lights, the car lights if you're near a road, billboards, all of those kinds of things pollute the sky and allow us to not see as faint. So by using this crowdsourced information, we can start to create like a map of where the best places are to look at the night sky. So then after you take your observations, take a note of the sky conditions, whether it's cloudy or clear. And if you have a dark sky, like you can see a whole lot of stars, or maybe you're closer to city or some lights, then it's sort of, you have some light pollution around. Then you're gonna go to our particular link. It's a Google form, and you'll answer the questions there. You'll input the zip code where you did your observations, and then answer about how many stars, your sky conditions.
I think that might be it. We try to keep it really simple, right? So,
really simple, yeah.
So you're so the trick is there's a link. We'll put it in the chat now. It'll also get sent to you right after the program tonight, and you can actually do this multiple times. It's not like a one-off. Or if you're with a group, if you want to take your kids out, if you want to sort of like do this with others, if you want to do it in multiple nights, we just ask for every observation. You just can basically fill out the form again. So it's your location, how many stars you see, what the conditions are. And then Meg, I'm going to ask you, I seem to think there's another question too, but Meg, do you remember? She's the one that came up with the form.
We were looking for night sky conditions and zip code, and I don't have it right in front of me, and I'll pull it up.
That's all right. So this should be kind of easy. Now, the other thing you can actually sort of notice it on the screen, and I don't want you to sort of just copy what's on the screen. That's not the idea here. But within this little shape, this little V, we'll call that an asterism that sort of makes the little V in the sky. Within that little shape, there are varying brightness of stars too. So we can get like a little sense by doing a little analysis of how many stars all of you people can see. We can get a little sense about how clear the skies are and at what magnitude the limit of your visibility is, where you're observing from. And so then 2 weeks from tonight, we're going to bring this, we'll tabulate everything. Hopefully we get a lot of responses to this. We'll tabulate everything and we'll just kind of show you what we discovered. And this really is a true citizen science experiment, right, Karen? I mean, this is what we do. We use a group of people to sort of like just do a simple observation, tell us what they see, and we can use the data to tell things. Is that right?
That's right. So this is kind of a project to get your feet wet, as it were, and do some practicing of how you can do some citizen science projects. And in the chat, we've also put some links to other citizen science projects that you can get involved in. So one of them is zooniverse.org. It started out with Galaxy Zoo, where you could look at a whole bunch of different galaxies from the Hubble Space Telescope and help classify them. It's now grown into not just astronomy, but also botany and history and meteorology and so many different things. One that is kind of analogous to the type of project that this is called Globe at Night. And that is actually, they have certain set days during the month that are designed to be, there's no moon up, and they have a particular constellation that you look at and do a similar rating of how dark is the sky by looking at a particular constellation. So
sounds perfect. So Alex is actually going to give us a little demo of just the cover pages for those two websites in a minute. But Karen, tell us, you've actually had experience doing a project? Was it fun? Did you like it?
Right. Yeah. So my favorite one is the Galaxy Zoo project. They getting a lot of data from telescopes. You have so much data that it's impossible for one astronomer to actually classify every single galaxy they see. Oh. So by putting this data up on the web, then they can crowdsource it and people can help contribute to those projects. And so that's kind of my nostalgic favorite. I've also had assigned that as extra credit or as homework in my classes as well. My students really enjoy it as well.
Karen, thank you. Thank you for joining me.
Mm-hmm.
And we'll have you back on a number of times. It's really sort of fun to do this. And I guess you'll have to come back 2 weeks from now, right? To kind of help deliver the results of our little project here. So, but
exactly.
I can't make it more serious. We really, really want you to do this. So take some friends out. You know what to do. Tomorrow, Friday, or Saturday, pick either one or all of them. Go out 7:45 to 8 o'clock at night, look towards the west. You've got the tools to find the little V shape. Look, and I'm going to recommend you go out and be in the dark for 10 or 15 minutes. It makes a huge difference. And so don't just run out there and take a look and then come running back in and say you didn't see anything. You got to spend a little time, examine, and sort of look. And so Aldebaran will be easy. Maybe a lot of you will just come up with one star, but if you start to see that V shape, if the shape comes in, kind of tell us how many stars you might see in the shape. And then there's a form. Log in, just do it. We'll find them, we'll tabulate the results, and we'll get back to you next week. Anything else? Did we cover that? Is that good? I think that's it. All right.
I think that's good.
Okay, Karen, thank you very, very much for joining us again. I want to take a moment. I'm going to invite Armand Dalla to the screen for a moment. Let me sort of change my screen so you can see my face. Armand is one of our students, and I asked him to just give you a real quick thing. Something really exciting happened during this past week. We got the announcement that a paper kind of related to the Hubble telescope, a new discovery, and I'm going to ask Armand to tell us what this is and why it's so exciting. Thanks, Armand.
Yeah, thank you, Rick. Let me share my screen and let's get started. So I believe exactly about a week ago, on the 30th of March, an article was published in the journal Nature, which was co-authored by one of our Regents professors at ASU, Dr. Roger Windhorst, and that showed the furthest star that's ever been captured on, taken a picture of by anybody ever. So the star is called WHL0137-LS, or also Arundel, which means morning star in Old English. It's about 50 times the mass of our sun, and the light from the star has taken about 12.9 billion years for it to reach us. So really far back in the universe's lifetime. It's the farthest and oldest star we've ever measured. But where is it in this image? So if we zoom in a little bit, you can see that it's right here, this tiny little dot that is sort of part of a line next to this galaxy cluster. But remember, all of the other dots in this image are entire galaxies. So how come this one star is able to be so visible as compared to the others? Well, it's through a technique called gravitational lensing. And that's when very massive body, which is closer to us, the gravity or the gravitational field from that body sort of bends the light from an object behind it. And in this case, magnifies it as well, so that it can be more visible to us. So these are some more examples of gravitational lensing. You can see how galaxies behind the one closer to us have been sort of distorted, and you can see them in sort of a circle around us. But why is this so important? It's because, remember, the further we look into space, the further we look into the past, it helps us learn more and more about the early stars and the sort of building blocks for the first galaxies. So by looking at this star, we're really able to learn more about early stars. And with the launch of the James Webb Space Telescope, we're going to be able to just learn a lot more about the early universe and the beginnings of stars, galaxies, and how we got to where we are today.
Excellent. Absolutely amazing. And so Roger has been working with the Hubble Space Telescope science for a long time. And this is, it's kind of, Hubble, as you know, is kind of end of life. And this is an amazing discovery. It's first, farthest, and as Armand said, farthest back in time that we've actually been able to see a star, a single star. Pretty awesome. Thank you, Armand. Thank you very much. Sure. Alex, I'm going to ask you to come on, just give us a real quick show some of those resources, the two citizen science ones, I think, and maybe a couple others. How you doing?
Yep. Perfect. Yeah. So I'll go over the ones that we kind of mentioned earlier. Let's see. Did I share the right screen?
No, that's your background screen.
Oh, there we go. Okay, no, so yeah, this first one's Zooniverse. This is the Citizen Science Project. There are a lot of different ones here. This one's Hawaii's bottomfish population. There's some giraffe populations. This is kind of one that just looking, I kind of found interested in. It's viewing disks around nearby stars. So basically you go in and you're given images and you select things that these teams are looking for, and then you basically help with that data processing. So these are just some of the featured projects, but there are a bunch on here, so be sure to check that out. And then the other one is Globe at Night. This is an international science campaign for like light pollution, and we've had a lot of good talks about that in the past about why that's important in dark sky communities and such. But this is it even has an app where you can submit data about light pollution in your area, and gives you a lot of good resources to help kind of measure that and then submit it. And so that gives a kind of a better global map of that. So these are kind of the two citizen science websites that we really want you to check out. Just in general, in addition to that resource, we also have, our events here at ASU and our kind of our employment opportunities, and also then our press and media opportunities. And so that's just some general resources that we always like to tag on, but mainly look at Zooniverse and this Globe at Night, because this gives you an opportunity to really get involved with the science and become a citizen scientist yourself. So yeah, be sure to check those out.
And if I remember right, all you need is a little dose of curiosity, and then you can do anything. Right? So.
Yeah, exactly. You don't need a big you don't need a degree. You don't need a big glasses or magnifying glass. You just need the interest to go out and do this. So be sure to do that if you have it.
Thank you, Alex. Great.
Mm-hmm.
So in 2 weeks, we're going to go back to the moon a little bit. We're going to celebrate the 50th anniversary of the Apollo 16 landing. We're going to also use that opportunity to give you an update on the Artemis mission, which actually we have a spacecraft on board. And hopefully by then we'll know, it could be some launch times and things. Review what that mission is going to do. We're also going to preview, there's a lunar eclipse, a total lunar eclipse in May, so we'll get you ready for that. So 2 weeks from now, kind of going back to the moon, but more importantly for tonight's episode is that also 2 weeks from now, we'll be sort of reviewing what you submitted as your project to go look at the Hyades and count those stars and report back to us. And we'll just sort of, as a group, sort of figure out what we learned and how we learned it and how it worked. One more big event coming up before I let you go this weekend on Saturday between 11 and 1 at ASU campus, at our main building. We're having an open house. It's run by our graduate students, and there will be lots of activities, lots of tables outside. You'll learn a lot about what they're working on, both in Earth and space, Geo and Astro. We'll have 2 free Marston exploration 3D shows available. And so that's this coming Saturday, 11 to 1 on the ASU campus at our building. It's called ISTB 4. And we're on the east part of campus. I think this is the first big public thing we have done in over 2 years. So we closed down for COVID in March 2 years ago, and this is the first big one. So come join us, come meet us, come sort of like see some of the stuff that we do on the site at ASU campus. So it was a pleasure being with you tonight. I'm glad many of you are frequent viewers. For those that were new tonight, please keep coming back every other week. We'll have something else interesting and fun to think about. And I'm going to use this opportunity to say goodnight and have a good day.